Hi friends, welcome to my another video. Today in this video, I will discuss about the difference between variable frequency drive VFD and soft starter. The confusion between these two is very obvious as VFD and soft starter both are used as a starting technique in order to start any motor. As we are well aware that the three-phase induction motor is a self-starting machine. As the three-phase induction motor is a self-starting machine, so these starter like VFD or soft starter is nothing to do with the starting up the three-phase induction motor. They are just used to suppress the inrush current which is producing at the time of starting. There are many methods which we are using in order to suppress the inrush current which is producing at the time of starting of induction motor. Which starting technique we will opt, it depend upon the rating of the motor, and it also depend on the cost, how much cost we can bear to control the motor. And the third one is which is very important, that which parameter is desired for us to control. Depending on these parameter we are choosing different technique of starting of induction motor. Here some techniques are auto transformer, soft starter, direct online starter, star delta starter, and there is other technique like VFD also. So here in our topic we are going to discuss what is the difference between VFD and soft starter. When we will understand the working operation of VFD and soft starter, then it will be easy to us to understand the difference between VFD and soft starter. So let us discuss first what is the working operation of VFD, and then we will discuss about the working operation of soft starter. In my previous video of VFD part 1, part 2 and part 3, I deeply cover what is VFD and how it's control the speed of the motor. I will give the link in the description, so watch that video for the deep concept. But here I will discuss the overview of the working operation of VFD and the soft starter. In VFD, we are giving three-phase AC supply as a input, and then inside the VFD, the rectifier section of VFD will convert this three-phase AC supply into pulsating DC. And in the filter section of the VFD, this pulsating DC is get converted into steady DC. And again in the inverter section, we will get a controlled AC supply where the voltage and frequency is as per our desire. And this controlled AC supply we will give to the motor in order to control the speed of the motor. But in case of soft starter, there is anti-parallel thyristors. There are 6 pairs of thyristors in the soft starter, and we are reducing the voltage at the time of starting by this thyristor in order to have less voltage at the time of starting of induction motor. And as we discussed in the part 1 video of VFD concept, that when the voltage at the motor terminal will be less, then the speed of the motor will be also less. So in the soft starter, we are slowly giving the voltage to the motor at the time of starting. So the motor will start slowly and it will after that gradually take its rated speed, and at the time of stopping also we are slowly decreasing the voltage, so the motor will gradually stop, and this will be considered as a soft starting and soft stopping of the motor. Now we will understand how this happen, how the soft starter slowly giving voltage at the time of starting of the induction motor, and how the soft starter slowly reducing the voltage which the motor have during operation in order to have a soft stopping of the motor. In the soft starter, there is a 3 pair of anti-parallel thyristors. Each pair of the thyristor is connected with the phase of the motor. In order to better understand the operation of soft starter, let us first understand the operation of thyristor. Here you see one thyristor, okay? Thyristor become a closed switch when we are giving gate pulse, a small voltage at the gate terminal of the thyristor. And when there is no voltage at the gate terminal of the thyristor will become as a open switch. Hope you understood the overview of thyristor operation. What I discussed? when we are giving a small voltage on the gate terminal of the thyristor is becoming acting like a closed switch. And when there is no any small pulse at the gate terminal of the thyristor will act like a open switch. Now, when we are giving AC supply as an input to the thyristor, then it will block it until and unless it will not pass this AC supply through it when we will give a small amount of voltage to the gate terminal of the thyristor. It is around 0.7 volt. The input voltage can be 450 volt, any voltage, okay, which will be written on the thyristor itself, but it will be very high. Like for example, it is 450 volt is the input volt, but this thyristor will not pass this 440 volt until we will give this 0.7 volt at the gate terminal of the thyristor. So at this moment we given a gate pulse to the thyristor, then the thyristor will act like a closed switch, so it will pass this amount of voltage, and before giving to the pulse it will not allow any current to pass through it. So in this time there is a zero voltage, and in this time after giving a gate pulse the thyristor allowed the voltage, and when the voltage reaches to zero crossing, again the thyristor will become as a open switch. In order to have power supply in the negative cycle also after zero crossing, again we have to give pulse, a small pulse to the gate terminal of the thyristor. So the moment which we will give, from that moment again the thyristor will become like a closed circuit, and it will allow the power supply, and it will allow the power supply till the next zero crossing. And after again zero crossing, if we will not give any power gate pulse to the thyristor, then it will not allow the supply. And at the moment we will give the gate pulse, then it will allow the power supply through it from that moment till the next zero crossing. So this is the working operation of the thyristor. Hope you understood. Now, how the soft starter reduce the input voltage at the motor terminal by using these thyristors. As I told you, in the soft starter there is 3 anti-parallel pair of thyristors. Now let us understand how the voltage will be reduced at the motor terminal by using soft starter. This is, I will discuss about one phase, and it will be valid for other two phase also. So this is our input supply to the motor in R phase, consider as a R phase, okay. Now at the time of starting we will give power supply, that is impulse voltage at the gate terminal at near to the zero crossing. So we will have a very less amount of voltage across the motor terminal, and gradually we will increase the voltage at the motor terminal by applying the impulse voltage at the gate terminal of the thyristor. So in first cycle we will give the impulse voltage at very near to the voltage crossing, zero crossing, okay. After that we will gradually increase the impulse voltage far from the zero crossing, so the motor will have more voltage in every cycle. So you can here see that in the first cycle there is very less voltage, in the second cycle there is bit more voltage compared to the first cycle, and again there is increasing and increasing in every cycle. In that way the soft starter increasing the voltage across the motor terminal at the time of starting in all three phases. So there is voltage is gradually increasing, so the motor will start also gradually, and this term in the electrical is called soft starting. Motor is not starting at in a moment, because if the motor will start from rest to its rated speed in very small second, might be 2 seconds or 3 seconds, then there will be two issues. One will be the electrical issues and second will be the mechanical issue. What is the electrical issue? As I told you, when the motor start, then there is a high inrush current at the time of starting, because we are giving directly a rated voltage to the motor. So this high inrush current at the time of starting will create a deterioration in the winding insulations of the motor, which will reduce the lifespan of the motor, and it will create wear and tears in the motor itself after frequent operation of the motor. The mechanical problem is that when the motor started with the jerk, then the bearing will have the stress, the motor body will have the stress, and the motor where it is standing, it will also have a stress. So the bearing will face the jerk, motor body will face the jerk, motor foundation where it is installed, it will face the jerk. Due to that, if the motor is connected with the other mechanical load, the shaft alignment may get improper due to this jerk. So we can say that by gradually increasing the speed of the motor through soft starter, it is reducing the electrical bad impact on the motor, and it is also reducing the mechanical bad impact of the motor. I hope you clearly understand the working operation of soft starter. Here in this video, I didn't discuss in deep about the working operation of VFD because I already covered this topic in my previous video. Link will be in the description. So no point to again discuss the same thing which I already discussed. So watch that video to get the more detail and deep detail regarding the working operation of VFD. So let us back to our original topic, that is the difference between VFD and soft starter. The first difference is the operation itself. The operation of VFD and the operation of soft starter is quite different. The second difference between the VFD and soft starter is the component. VFD is a combination of diodes, DC bus and the IGBTs. But the soft starter is just a 6 anti-parallel thyristors. So by the component there is a difference. The third difference between the VFD and soft starter is that the VFD is controlling the speed of the motor by changing voltage and frequency, which I clearly discussed in my previous video. In the soft starter, as we discussed, we see the soft starter only regulating the voltage of the motor. So VFD is changing voltage as well as frequency, but the soft starter only regulating the voltage of the induction motor in order to give soft starting and soft stopping of the motor. The fourth difference between the VFD and soft starter is that VFD suppressing inrush current with speed control, but the soft starter suppressing the inrush current without having any control on the speed. What does it mean? Let me explain this one. As in the VFD video, I clearly discussed that we are generating a controlled AC supply, means with a controlled voltage and controlled frequency. Okay, and by this we are controlling the speed of the motor. So at the time of starting, we are giving very low frequency and very low voltage. So the motor will start slowly, and slowly we will increase the voltage and frequency to have the motor gradually increase its speed. But during operation, again we can decrease the voltage and decrease the frequency in order to decrease the motor speed. And during operation, again we can increase the voltage and frequency in order to again increase the speed of the motor. So we can say that with the VFD, not only at the time of starting but also during operation, we can change the voltage and frequency of the power supply in order to change the speed of the motor. Means we have a facility to change the speed of the motor at any point, at the time of starting, during operation, at the time of stopping also. But in case of soft starter, we are gradually increasing the voltage by using this anti-parallel thyristors, and once the motor start rotating in its rated speed, then the soft starter cannot do anything. Meaning the function of starter is only at the time of starting, and when we are going to stop the motor, then the soft starter will gradually decrease the voltage in order to make the motor soft stopping. But during the operation, we cannot use soft starter. In some cases, after starting of the motor, the soft starter get bypass, means it completely get electrically detached from the system. And when we are going to stop the motor, then again the motor will come back into the electrical circuit and it will complete its function. But during operation, sometime soft starter in the circuit always, but in some time also the soft starter completely get detached electrically from the system. So what is the difference between soft starter and VFD? That the VFD is always in the circuit, but the soft starter is only active in starting up the motor and stopping of the motor. Okay, and it is suppressing the inrush current without having any control on the speed of the motor during operation. But VFD is suppressing the inrush current, but it also have control on the speed of the motor during operation. Hope you understood this concept, and this difference is the major difference between VFD and soft starter, and that's why due to this difference the VFD become winner, and due to this difference the VFD become more and more popular compared to soft starter, as it has a suppressing inrush current facility with speed control, but the soft starter just have the inrush current suppressing facility. Now let us move to the other difference. The other difference between the VFD and soft starter, that the motor can run at various frequency. But in soft starter case, the motor will run only at the fixed frequency, which is the power frequency. If the power frequency is 50 Hz, the motor will run always in the 50 Hz at the time of starting, stopping, and during the operation. But as I told you in my previous discussion also, VFD have a control on frequency, so motor can run at any frequency till the power frequency. If the power frequency is 50 Hz, then the motor can run at any frequency below than the power frequency. And some VFDs are also coming which is increasing the frequency more than the power frequency also, but that VFD application is very limited and it is used in very precise area. The reason is very simple, because motor are designed with some rated speed, and that rated speed is considered by using the power frequency, that is 50 Hz or in some countries 60 Hz. If you will run the motor at more frequency, that is 60 Hz, 70 Hz, 80 Hz, then the rated speed of the motor will become very high, which will make a wear and tears, mechanical wear and tears in the motor. So it is not recommended to operate the motor more than its rated speed. Okay, hope you understood this one. The next difference between the VFD and soft starter is that VFD giving high starting torque, but the soft starter giving low or medium starting torque. This is very important, which I deeply discuss in part 1 and part 2 video of VFD. Must watch that video. But let me overview this concept. In case of VFD, VFD is changing voltage and frequency in a equal proportion. So the ratio of voltage and frequency is always constant. And if we will reduce only the voltage, then flux will go down, and the flux is responsible for the torque. If the flux is low, the torque will be low, and if the flux is high, then the torque will be high. So in case of VFD, VFD reducing the voltage and reducing the frequency in constant ratio. So always the ratio of voltage and frequency is constant, which is flux. So the flux always be fixed in the case of VFD controlling. But as we see in the soft starter, the voltage is only going down, but the frequency is not changing. So due to that, the flux is going down with the voltage. Let me give you an example to better understand this difference. Let's say in VFD, we are giving a small voltage. The rated voltage is 440 volt. And at the time of starting, VFD is giving 150 volt. Let's say. And the soft starter also giving a voltage of 150 volt. But as the frequency is also reducing from rated frequency 50 Hz to, let's say, 30 Hz or 25 Hz, let's say example 25 Hz, then the torque which the motor have during starting is higher, but at the same voltage the torque in case of soft starter is low because the frequency here is high, which is the rated frequency. So at the same voltage, VFD having a high torque in the motor, but in case of soft starter, at the same voltage, the soft starter will create medium or low torque in the motor. Now let us move to the other difference. VFD can replace soft starter, but soft starter can't replace VFD. This is very clear now because we discussed these things from beginning. As the VFD can control the inrush current and have the control on the speed, means VFD has two facility. It is controlling or suppressing the inrush current, and it has a control on the speed of the motor. And the soft starter is only have a control on the inrush current, which is producing at the time of starting. So wherever the soft starter is using, we can change with the VFD, as VFD is also in suppressing the current at the time of starting. But wherever the VFD is using, we cannot replace with the soft starter, as when we will replace, we will get one facility, that is suppressing the inrush current at the time of starting of induction motor, but it will not give the speed control of the motor which is required. Okay, hope you understood this concept. Now let us move to the other difference, that the VFD is active throughout the operation, but the soft starter is active only at the starting time and stopping time, which I already discussed. And some soft starter is get bypassed during operation, okay, electrically. Now let us move to the other difference between VFD and soft starter, that is the more energy saving in case of VFD and comparatively less energy saving in case of soft starter. Why this difference? Suppose there is a motor which have a rated speed of, let's say, 3000 rpm. Okay, now but during operation sometime this motor is required to operate at only 1500 rpm, not required to run the motor and in 3000 rpm, as we are decreasing the speed by decreasing the power supply. So this will be the saving to the power supply. But in case of soft starter, we started the motor and motor reached to its 3000 rpm speed, rated speed. Now if the operation required only 1500 rpm from the motor, but we don't have anything to control the speed of the motor, so this, the requirement is 1500 but we are rotating the motor at 3000, so the power is always same, even the requirement is less or even the requirement is more. So in this case the soft starter not giving energy saving facility, but the VFD is giving. The other difference between the VFD and soft starter is that VFD is a magical box for the motor. It is giving every possible protection to the motor, and soft starter also giving, but less than VFD. In VFD you will get short circuit protection, overload protection, under voltage, under current protection, phase failure protection, which is the earth fault protection, you can say that, thermal protection, earth leakage protection, and earth fault protection, also high torque protection. But in the soft starter you will get short circuit protection, overload protection, under current and under voltage protection, phase failure protection, earth fault protection. Here the two protection is more. First one is thermal and second one is high torque protection. But we can say that the soft starter also giving enough protection, but if we will compare, we can say that the VFD is more better than the soft starter. Now compared to speed, VFD has the larger size and soft starter has the smaller size. Another difference between the VFD and soft starter is that the operating cost is less in the VFD, which I discuss you here, that when the motor is required to rotate in only 1500 and we can reduce the speed by using the VFD, so means we are reducing the operating cost. But in the case of soft starter, even the requirement to run the motor at 1500, we cannot run it at 1500. The motor is running at the rated speed, so the operating cost of the motor in soft starter technique is high. So we can say that the operating cost of VFD is less, but the operating cost for the soft starter is more. The other difference between the VFD and soft starter is that VFD is generating harmonics in the system, but soft starter is not generating any harmonics. This is the major difference, and this makes the soft starter better in case of VFD, but this is the first time we are finding the soft starter is better than the VFD. The second thing, as there is a no harmonics, so soft starter do not require any filter to filter the harmonics, but VFD required, as it's generating and injecting the harmonics in the line power supply, so it required filter. So this is the second difference where the soft starter is comparatively better than the VFD. The third difference, the other difference between the soft starter and VFD is that VFD is costlier than the soft starter. As we see, there is a many facilities in the VFD, so VFD is costly compared to soft starter. This is all about this video. I hope you find this video informative and you learn something new from this video. If you really like this video, then please give thumbs up, subscribe to my channel, and surely share with your electrical friends. We will meet in any other video. Till then, take care, keep learning, and bye-bye. Thank you so much.